Okay, welcome to this week's lesson. We're going to be talking about charge and electrical interactions. First thing I want you to do is go ahead and take out your Cornell notebook, set it up with this topic and these learning targets. So the first thing we have to understand is the basic structure of the atom, the protons, electrons, and neutrons. The important thing here is that the protons and the neutrons are immobile. They can't go anywhere. Electrons are mobile, and that's what's going to lead to these difference in charges. Protons are obviously positively charged and electrons are negatively charged. Here's a basic structure of an atom, just as a little refresher. The electrons are floating about on the outside, and the neutrons and protons are located inside the nucleus. So charge is a characteristic of matter that depends on the average electrons and protons within either that atom or the matter itself. So if something has more electrons than protons, it's going to be negatively charged. If it has more protons than electrons, it's going to be positively charged. So it has to depend on the ratio between the electrons and protons. When we're talking about things that are insulators or conductors, it depends on how electrons can move about them. Insulators, electrons can't move freely. These are things like glass, wood, and plastics. If we add electrons to these, they just get stuck inside the glass, the wood, or the plastics, and they get held there. Conductors allow electrons to move freely. And so if we add electrons, they're able to migrate away from each other. They're able to go through it. These are metals like you would find in any wire, like your phone charger. Gold is a really good conductor, copper, and silver. So I want to take a look at some of these atomic structures in a bit more detail. Take a look at the conductors, and then take a look at the insulators. And what do you notice about the outer shell for each of these? Take a second to think about that. Well, what I'm hoping you're noticing is that for the conductors, the outer shell only has one electron, and that's really important. A conductor is going to be really good at conducting electrons if that outer shell is not full. If there's one electron in that outer shell, generally it's going to be a really good conductor. For the insulators, that outer shell has somewhere around 4 to 6 in sulfur, 7 in chlorine. So all of those atoms make up plastic, and that's why those are insulators. Those electrons don't want to go anywhere, so they're not going to move about very freely. So the triboelectric effect is really interesting. I think we've all seen this done before, where you take a balloon, and I'll go ahead and do that for you here. If I have a balloon and I rub it against my head like this, and then I lift it up, you can see that my hair is sticking to the balloon, and this has to do with the movement of electrons. So electrons are moving from my hair into the balloon. The balloon itself is made out of plastic, so it's an insulator, so it's going to hold on to those electrons. Since it's an insulator, it becomes more negatively charged because it's gaining those electrons from my hair. My hair then becomes more positively charged, and because they're opposite charges, they're going to attract each other. Okay, until eventually the balloon loses all of its electrons that it just gained, and then there's no difference in charge between my hair and the balloon. All right, I'm going to continue this in the next video.